Polynomials? They should call them polynomials. Whoa! Polynomials are simple functions with predictable characteristics. However, they can be quite confusing if you don't understand their key characteristics. A polynomial is the sum of whole positive powers of x. In general, I can summarize using the following equation, where a, b, and so on are the coefficients in front of the x terms, and I start with x to the power of n and decrease the exponent by 1 until I'm left with an exponent of 0, or a constant term. Considering two examples, the function on the left is a polynomial because you can see I'm adding or subtracting a series of x terms with whole positive powers. The function on the right is not a polynomial. The exponent on the first x term is -3, which is not a positive power of x. Note that the terms do not have to be arranged in order of greatest exponent to smallest exponent. If I wanted to, I could rearrange the terms in this way to have the exponent on the x value decrease from left to right, but it's not necessary. Here are two key characteristics of polynomials that are going to help you develop an understanding. The first one is the degree, which I've already referred to in the example we just looked at. The degree is the highest power of x. So in the function on the left, the degree is 7. This is the reason why I chose to rewrite this expression with the highest degree on the left and the lowest degree on the right. This is a common misconception that if a polynomial is written in this form, the degree would be 3. But remember, the definition of degree is the highest power on x. The degree can also be used to determine the number of turning points on a function's graph. So for instance, this function here has 1 turning point, 2 turning points, 3 turning points. Turning point just being a point where the function changes direction. Because this function has 3 turning points, the degree must be 4, because the degree minus 1 will tell me the number of turning points. The second key characteristic is the leading coefficient. This is the number in front of the highest power of x. This will help us predict where the function starts and ends. So with a deep understanding of these two key characteristics, your understanding of polynomial functions should be quite strong. Taking a look at polynomials, and starting with the simplest possible polynomial, which is a line, if I increase the power on x, what you'll see is a rather interesting pattern. All of the functions with an odd degree, like 1, 3, 5, all seem to start in the third quadrant and finish in the first quadrant. As it turns out, that is not a coincidence. These functions are what we call symmetrical about the origin. If you picture holding your pencil on the origin and spinning this function with your finger like a twister spinner, you would produce the same function as the original. All the polynomials with an even degree are what we call symmetrical about the y-axis. This means I could simply flip the function over the y-axis and produce the same graph. Combining our understanding of even and odd functions with our understanding of the key characteristics of polynomials, we're able to predict where any polynomial will start and end. This is known as the end behavior. This is summarized in the following chart. For example, if the degree of a polynomial is even and has a positive leading coefficient, we know it should start in quadrant 2 and end in quadrant 1. An example of this would be a quadratic. If we have the same degree of polynomial with a negative leading coefficient, we know it's going to start in quadrant 3 and end in quadrant 4. If you think about your understanding of reflections of quadratics, this should make intuitive sense. And of course, if I have an odd degree polynomial with a positive leading coefficient, I should be starting in quadrant 3 and ending in quadrant 1. For example, the cubic function. If I have a negative leading coefficient, I should be starting in quadrant 2 and ending in quadrant 4. Again, thinking about your understanding of reflections, this should make intuitive sense for the cubic. So that's a quick summary of the key characteristics of polynomials and how they can be used to understand what their graphs look like. If this video helped in any way, feel free to like and subscribe for more mathematical chaos. And as usual, thanks for watching.